Have you ever looked at a tattoo and just wondered? How does ink injected into our skin manage to last a lifetime? Well, today we're going to get into the science of it, this fascinating biological paradox that lots of us wear right on our bodies.
So let's just dive right into this paradox. Because when you really stop and think about how our skin actually works, the fact that a tattoo is permanent becomes a genuine biological mystery.
I mean, here's the core puzzle, right? Your skin is an organ that is constantly, and I mean constantly, renewing itself. So how on earth does that intricate design on your arm not just flake off or fade away completely in like a month?
And the scale of this renewal, it's just staggering. Your body sheds roughly 40,000 dead skin cells every single minute. It's an incredible amount of turnover. When you think about that, the idea of a permanent tattoo seems almost impossible.
So to solve this mystery, we can't be looking at the surface. The real secret is hidden a little deeper, down in the very architecture of our skin. See, our skin has two main layers we need to worry about here. First, you've got the epidermis. That's the outer layer, the one that completely sheds and replaces itself every 2 to 4 weeks. But right underneath that, you have the dermis, and this layer is way more stable. Think of it like a strong, deep anchor made of collagen and fibers. That's our target.
And that's the absolute key. For a tattoo to last, the ink has to get past that flaky epidermis and be placed precisely into the stable dermis. If it's too shallow, it'll just flake off. Too deep, and it'll blur out. You've got to hit that dermal sweet spot.
But getting the ink to the right place, that's just step one. The second that needle punctures the skin, your body treats it as an injury. It sounds the alarm, and the body's first responders, well, they come rushing in.
And let's meet the star of our show, the macrophage. Its name literally means big eater in Greek, and that is exactly what it does. These cells are your immune system's cleanup crew, and they rush to the site of any perceived invasion. So these big eaters show up, they see all these foreign ink particles, and they immediately think, intruder. Their only job is to get rid of it, so they try to swallow the ink particles whole. The fancy science term for this is phagocytosis.
Now, this is where it gets really wild. The body's attempt to get rid of the ink is, ironically, the very thing that makes the tattoo stay put for decades. It's an incredible biological twist.
So picture this. A macrophage rushes to the scene, and it successfully swallows an ink particle, trapping it inside its cellular wall. Mission accomplished, right?
Well, not exactly. Here's the catch. Unlike a virus or a bacteria that it could digest, the ink pigment is too big and it's chemically stable. The macrophage can't break it down. It has basically eaten something it can't digest. The ink is now trapped, and so is the cell, stuck right there in the dermis.
Which, of course, leads to the next big question. These cells, they're not immortal. They eventually die. So what happens to all that ink they've been holding on to? Does it just get washed away then?
Nope. What happens is this amazing continuous cycle. An old macrophage dies, and for a split second, it releases the ink particle. But almost instantly, a new nearby macrophage rushes in and gobbles up that very same particle. It's like a microscopic handoff that happens over and over and over again for years, locking the tattoo in place.
And the macrophages aren't even working alone. Other cells in the dermis called fibroblasts, the ones that actually build your skin structure, they also absorb some of the ink. You can think of them as a secondary anchor or like a backup storage locker, helping to hold the whole design right where it belongs.
Okay, so if this cycle is so clever, so effective, why do tattoos still fade over time? Why isn't permanent really truly permanent?
Well, a few things are working against it. The biggest one is UV radiation from sunlight. It basically acts like a very, very slow laser, breaking down pigment into smaller pieces that your body can eventually clear away. Also, that handoff cycle, it isn't 100% perfect, so over decades, tiny amounts of ink do get lost. And of course, just plain old skin aging can cause the ink to shift around a little, softening the lines.
So when you put this all together, you realize you have to kind of reframe how you think about what a tattoo actually is. It is not just a static stain on your skin, it's so much more than that.
A tattoo is really a living, dynamic process. Think of it this way. You are hosting a lifelong microscopic stalemate between your immune cells and the pigment you chose to put there. It's not just art on your skin, it's art held in place by your skin. A beautiful biological truce that's designed to last a lifetime.